All right, I welcome you again to my channel. All right, so JAMB Mathematics. All right, like I said in the introductory video, we have 5 sections: numbers and numeration, algebra, geometry and trigonometry, calculus, and statistics. Okay, so we are beginning immediately with the first. All right, now under numbers and numeration, like I said, there are 5 topics we are going to be seeing. The first is number systems or number bases. Okay, so you have number basis. Now the reason I like to list the extent that a particular whether course that you're doing or a subject is going to require or involve or consist is so that you will have the full grasp of what you are doing. If you know the number of topics in numbers and numeration, know the ones under algebra, know the ones here and this, what it does to you is that it gives you the ability to measure, being able to measure whatever you're doing, to know how far you've gone, so that if somebody asks you today, say you have 1 month to JAMB exam and someone is asking you how prepared are you in math, you should be able to say I'm 60% ready, I'm 80% ready, I'm 90%. And how do you know that when you don't know the topics involved? So that's why I take time to give you all of that. So remember, we said the first topic is number system, number 2 fraction, decimals, approximations and percentages, number 3 indices, logarithms and sorts, number 4 sets. So these are the 4 topics here, and we're beginning with this first one. Now when it comes to the first one, it is divided basically into 2. So we have the first part. Okay, so it involves conversion from one base to another, and then number 2 is operations in different number bases, as from base 2 to base 10. Okay, so these are the 2 broad areas that you're supposed to look into when it comes to number bases. Are you able to convert numbers from one base to another, whether from base 3 to base 5 or base 6 to base 2 or from base 2 to base 10, whatever? And then after that, are you able to perform some operations? Remember, when we're talking about operations, in this case we are referring to addition, subtraction, multiplication and division of numbers in different number bases. Okay, so that's exactly what we are going to be looking into here. Okay, so let's quickly get into it. Okay, now like I said, we are having 2 major things to cover under number bases: conversion from one base to another, and then number 2, basic operations in different number bases, right from base 2 to base 10. Now, what are the objectives of the lesson? Is that at the end, every student should be able to perform 4 basic operations. Remember, I said the multiplication, addition, subtraction, and division, and then should be able to convert from one base to another. Now, when it comes to that conversion, let me quickly say there are 3 different ways we do conversions under number bases. One is to convert from base 10 to any other base. Remember that generally what we have is numbers in base 10. If we write any number for you, say 500, we count numbers normally. The normal counting system is in base 10. Okay, so and whenever a number is written without a base, it means it is in base 10. Okay, so now if we can now decide to convert from base 10 to any other base. It could be to base 2, 3, 4, 5, 8, 9, and so on. All right. Now, that's the first part of conversion, and that's what this example will take care of. Now, the second part is to convert from any other base back to base 10. So you already have from base 10 to any base. Now you're moving from base or any other back to base 10. And then the third form of conversion is where we now move from a base to another other than 10. These 2 involves base 10. So now what if we now say convert from base 2 to base 8? Okay, so now you are moving 2 to base 8. So these are the different kinds of conversion, and the reason why we do the third one last is because it will involve these 2. Okay, so we are going to get into it, and then you can see the last objectives is that, or the last objective, sorry, is that you should be able to perform operations in modular arithmetic. This is why having the syllabus for every course you're doing, even when you come to the university, is important, because there are some things that are hidden. Number basis does not involve modular arithmetic, even though they have the same approach. So but here they are now putting it in this point, because modular arithmetic actually involves putting numbers in a particular base, but you are going to be recording the remainders. All right, so and that's why it's important. Like I said, you should have seen the curriculum in full in the introductory video. Write it down and do your work using that curriculum. Okay, so let's get into what we have. Now, solution. This one requires what we call successive division and recording of remainders. So what do we mean? You will keep dividing until you can no longer divide. In fact, until it gets to 0. And as you're dividing, you will be recording your remainder. So see what I'm saying? For example, A. Okay, so what do I do? Just draw your division, long division line, and write 49 inside. And then you are going to be dividing by the base that you are going to. So since I'm going to base 2, I'll divide by 2. All right, so we start. You divide 49 by 2. What would you get? That will give us 2 here. Then here you have 4, and there will be a remainder of 1. So you record that remainder that way. Okay, so you will go again. 2 divide 24, you have 12. Is there a remainder? No. So your remainder is 0. So when there is no remainder, that's 0. Okay, you go again, because there's still a value here. 2 into 12 is 6, and the remainder again is 0. And 2 into 6 is 3, and the remainder again is also 0. Then you keep going. 2 into 3 is 1, and the remainder here is 1. And finally, you can see that 2 can no longer divide 1. So once you get to the point where this number can no longer divide what you have, what do? You will now write 0, remainder, whatever you couldn't divide here. So that is now 1 in this case. Okay, so now this is the first step, successive division and recording of remainders. And then the next step, which is what gives you your answer, is to record the remainders upwards. Okay, so I will just note down the remainders that I have, and in this case, what I will now get is 1, 1, and I will put my base. The base is what? 2. Therefore, what it means is that 49 in base 10 is equal to 11,001 in base 2. Okay, so that's how to do this. Okay, here again, you have example B. So I'm going to do the second one, or let me do the third one. So you do B and D for me as exercise. So, okay, so for C now, you have this time around 49, and you're going to be dividing by 8. So let's go. 8 into 49. 8 can divide into 48 to give us 6. And therefore, it means there will be a remainder of 1. And so again, can 8 divide 6? No. So you can see exactly what happened here has occurred here. 8 can no longer divide 6. And so you stop and you have 0 remainder, the whole of this, which is 6. So what it therefore means is that if I count up now, it means that my 49 in base 10 is simply equal to 6 and 1 in base 8. Okay, and that is my solution. So this is how to run conversion from base 10 back to any base at all. So if you are giving it to get it to base 9 or base 6 in this case, you divide by 6. Base 5, you divide by 5. Base 9, you divide by 9. All right, and so record your remainder. So whatever you have here will form the value for your conversion. Okay, quickly let's go into the second example. He says, the second example, he says that we should convert the following to base 10. Okay, so we are moving backward now. Okay, I would have loved that we will start with any of this. Of course, when we do one here, so I'm going to now take one more here, then you will do the remaining 2. Okay, so solution. All right, so what do we do here? We have A, that is 31 base 8. So we want to take it to base 10. Now, this one goes with successive division This one goes with successive multiplication. So you are going to be multiplying and then adding, but let me show you how it goes. So the first thing you do is that you will number the digits you have here starting from 0. That will not be necessary by the time you master it. So all you do, number this 0, then you're starting from here and you're going to your left. So then 1, if there was another number, you number, and so on. Okay, so when you do that numbering, see what that numbering is going to do for you. You will pick each of the digits that you have here. If you pick 3 now, you multiply by the base, which is 8, and raise it to the power of the number you gave it here. So in this case, it is what? 1. So you raise it to the power of 1. And then you now add. So you pick this 1, multiply by the same base, just the same process until you pick all the digits you have there. And then in this case, you raise to the power of 0. Okay, so that's the way it works. Alternatively, if you don't want to use this numbering, see what you will do. If you pick the digits, you cover it and count the number of digits left. So in this case, you have only 1 digit left. So you raise this 8 to the power 1. When you now pick 1, you will now cover it and then count the number of digits. No digit is left, so it will be power 0. All right, so and that is going to be, then you simplify what you have. So this will give us 3 times 8 to the power of 1 is 8. 1 times 8 to the power of 0 is what? 1. And so this is going to give us 24 plus 1, which is equal to 25. You can put base 10 if you want, or you may choose not to. Okay, so that means 31 in base 8 is the same thing as 25 in base what? 10. All right, and that's the solution to this. Okay, so I would have loved to do this, but this also in base 8, so let me leave it. But then of course we can do it by passing. All right, let's quickly do the second one here. So there we have 2, 1, 3 in base 4, and we want to change it to base 10. So the same thing, so pick your 2, multiply by the base, then you raise to the power of 1, 2, then plus pick your 3, multiply by the base, raise to the power of 1, then pick your 1, multiply by, sorry, this should be addition, not multiplication. Pick your 1, multiply by 4, raise to the power of 0. So you just keep going until you get down to 0. All right, and then that's going to give us, so here I have 2 multiplied by 4 to the power of 2 is 16, plus 3 multiplied by, all right, and then finally 1 times 4 to the power of 0 is always 1. Okay, so and that's going to give us, this is 32, that's 2 times 16, plus 3 times 4 is 12, 1 times 1 is 1. And by the time we sum all of this, this will give us 44, and so we'll have 45 in base 10 as the value of 231 in base 4. Okay, so that's exactly how to go about conversion from different bases back to base 10. Okay, so quickly, we are now going to look at the third kind of conversion where you move from a base to another that is not base 10. Okay, so let's look at the next example. All right, so here we have the third type of conversion. So in this case, you are going to be converting from a different base. Here we are told to convert to the base in bracket. So in the first one, from base 4 to base 6, base 3 to base 5, and base 7 to base 9. Okay, so what do we do there? Now, look at, in this case, like I said, it's going to involve the 2 we saw here earlier. Okay, so what do you do first here? You will move the number from base 4 to base 10 first. And you know that from base 10, you can actually go to any base. So it's like, I usually give that instance. For instance, you are in a room, maybe at one corner of the room, and the room has just a door, or whether 2, it doesn't matter. So, and you want to get out of the room to a particular place. Now, the first thing that comes to mind is not where you're going. No, the first is that you must first of all leave the door. If you don't leave the door, you don't have a direction yet. Okay, so now we get out of the door and then we can get to anywhere. That's exactly what this is. So base 10 is like the door. So you must come to base 10 first, and from 10 we can move anywhere. So that's actually the principle that guide this one. Okay, so look at the first one, 301 base 4, and we want to go to base 6. Okay, so what do? We first of all move it to base 10. So I have 301, 3 times 4 to the power of 2, remember, okay, plus 0 times 4 to the power of 1, plus finally 1 times 4 to the power of 0. Okay, so watch what will happen there. Now this is already 0, so for time's sake you don't need to waste your time doing this. The whole of anything multiplied by 0 is 0. So this is going to give us 3 times 4 to the power of 2 is 16. Then this is 1 times 1. And that's going to give me, this is 48 plus 1. So I have 49 in base 10. Okay, beautiful. Right, so now I would have to now convert that 49 in base 10 back to base 6. And that is going to give me 49 in base 10. In base 6 is going to be 49. I will now divide by 6. So 6 dividing 49 is going to give us 8 remainder 1. 6 will go again into 8. You get 1 remainder 2. And 6 will go into 1. It cannot go, so you write 0 remainder 1. So you remember our pattern, you check up. So by the time you go up, you have 1, 2, 1, now in base 6. Therefore, what that means is that 301 in base 4 is equal to 121 in base 6. And that is the solution. Right, so that's exactly how that follows. And if you do the same for the other two, you should be able to get the same result. I want us to see operations involving number bases in this video. I thought of doing it in a new video, but I think all of them should be able to enter in this video. So here we want to look at how to handle operations such as division, multiplication, and the rest. So let's look at some examples. Okay, so now these are some of the questions we have in operations. Now, remember, like I said, we are going to be dealing with addition, subtraction, multiplication, and division. So we are using this example to look at all of them in one. Okay, then later we'll now do other examples. And remember that I'm going to also be bringing you some JAMB real questions. In fact, I have about past questions of about 9 years in food. So what I did was to pick out the questions from number system. In each of the years, I discovered that there's always one question in a particular year. I only saw that between 2015 and 2017, that's 2015, 2016, 2017, there was no question on number system. But 2010 down to 2014 had, then 2018 upwards also had. So we are going to be seeing questions on that maybe in the next video. But of course, it follows the same pattern. The only thing they do is just to tweak some things and then allow you to apply your understanding from what we have taught you here to be able to solve those questions. Okay, so quickly let's look at this. How do you do addition in number basis? Now, solution. Now, what I used to do then as a student is to first of all convert them to base 10, then add and then bring it back to base 5, since this one is in base 5. Now subtract, bring back, multiply, bring back, divide, bring back. But that will be taking your time. You can actually do all of this in base 5 without having to convert and all of that. Okay, so look at how we handle it. So for the first one, what they're asking you here is just to divide this by this in base 5. So that means 314 in base 5 plus, okay, that's addition. Okay, let me quickly just put it in addition form. So what we want to do is 314 plus 214 in base 5. Okay, now how do you do it? It actually follows the same pattern of addition in base 10. The only thing is that all your sub calculations will be in base 5. So you add the normal way you add in base 10. For instance, 4 plus 4 is 8. That's the same thing we do in base 10. But the only thing is that you are not going to record 8 here. You know why? Because 8 is bigger than 5 and you are in base 5. Okay, so remember I told you that 8 cannot be a digit cannot be in a base where it is bigger. So you can only find 0, 1, 2, 3, 4 in base 5. You can't find 6. You can't even find 5. You can't find 7, not to talk of 8. So what do? Since 8 is bigger than the base, all you need to do is divide this 8 by the base and just record the remainder and carry whatever you will get. So if I divide 8 by 5, I'm going to get 1 remainder 3. Okay, so it is the remainder that I will record here. And that one that I got, I will carry it over here. Okay, so and then when it comes here, it becomes 2. Okay, so see what you now do. 2 minus this, sorry, remember you are doing addition. So 2 plus this is going to give us 4. Okay, and then finally you will bring down your 3 here. Okay, so and that is your solution in base 5. Okay, so you can put base 5. All right, so this was actually where the test is. Okay, so how to do this? So once it is more than the base, you divide by the base, record the remainder and carry whatever you got in that division. All right, okay, so let's go to the second one, which is subtraction. So here we have, okay, m minus n, and our m minus n is 314 minus 24. Okay, the same method, you subtract like you do in base 10, but your sub calculations or whatever answer you will write will be in base 5. So 4 minus 4 is 0, so 0 is a digit in base 5, so you will write it. Number 1 minus 2, it can't go. What do? You borrow 1 from here, so you have 2 left. Now, that 1, when it comes here, what does it become? That's another place your base comes in place now, or into a play or into a role. Because when you're doing it in base 10, whenever you borrow 1, you know it usually will turn to 10. It turns to 10 because you are in base 10. But in this case, you are in base 5. So it should turn to what? 5. Whatever is the base, that's whatever number you borrow will turn to. So in this case, it will become 5. And 5 plus this one will be 6. Okay, so you are borrowing 1, so and you're adding it to this. That one is becoming 5 and you're adding it to this one, it will be 6. So 6 minus 2 will give you 4, and then you bring down your 2. Okay, so and that's your answer in base 5. Okay, all right, so let's leave it that way. Now we are doing the same thing, multiplying like your normal base 10 and then doing all the sub calculations in base 5. All right, so 4 multiplied by 4 is 16. Remember, you use this to multiply the whole of this. Don't mind me. This will multiply this, multiply this, multiply this, and you record. Then 2 will multiply, you also record. So let's go. 4 times 4 is 16. Okay, so now that 16, what would you do with it? You are not going to write 6 and carry 1. You only do that in base 10. So you will bring that 16 and divide it by the base, which is 5. So 5 divided 16 will give us 3 remainder 1. Okay, so it is that 1 that you will write here. So you will now carry 3. So that 3 will come here. So you now do 4 times 1 is 4, and plus that 3, which is 7. So that 7 is again more than 5. You divide by 5, which will give you 1 remainder 2. So it is that 2 you will write here. Are you with me? Okay. Then you will carry this one that you got over to this place. And then 4 will go again times 3 is 12. 12 plus 1 is 13. 13 is again more than 5. You divide by 5 and that will give you 2 remainder 3. So you will now write 3 here. That's the remainder, and carry over these 2 to this place, and that 2 you will bring down. Okay, so we are done with 4. Okay, so let's remove everything up there. All right, so now we now come over to 2. So 2 multiply 4 is 8. 8 is again more than 5. So we have 1 remainder 3. So we write 3. Remember you're writing it under this column, all right? So 3 carry 1. That 1 will come over here. And then 2 times 1 is 2 plus that 1 is 3. So 3 is less than 5. So you write it. Then 2 finally times 3 is 6. 6 is more than 5, so that will give you 1 remainder 1. With time, you will not need to be doing all this. You will know which one to write. Okay, so here I will now write 1, and then I will carry 1 over, which I will drop here. Okay, and you are done with multiplication. And you know what we usually do after multiplying? We do what? We add if we have more than 2 rows, or sorry, more than 1 row. Okay, so in adding, you will still add in base 5. Okay, so this is 1, you drop it. 2 plus 3 is 5. 5 cannot be in base 5. So you reduce it to digits in base 5, which is dividing by 5, and that will give you 1 remainder 0. Okay, so you write 0 carry 1. So 1 plus 3 is 4, plus 3 again is 7. So which will give us 1 remainder 2. You write 2 and carry 1. Then this is 3, 4. 4 can come here, and you bring down your 1. Therefore, the product of 3, 1, 4 and 24 in base 5 is equal to, we can write it, therefore 3, 1, 4 base 5 times 24 base 5 is equal to 14201 in base 5. And that is the solution. Okay, so that's the solution for multiplication. And lastly, we will look at how to divide. What do? You do your normal long division. Normal long division we do in base 10, and bring in the one you are dividing, which is the dividend, and then your divisor will be out here. Okay, so look at how division works under basis. Now, you're starting with the first digit. So, you're only asking yourself question and answer. Can 24 divide 3? No, it can't. Then you leave it or you record 0. If you choose, some people would record 0. Okay? Now, whenever it can, you record 1. All right, so see what I'm saying. So, can 24 divide 3? It can't. Can it divide 31? That's you join 1 down to it. Can it divide 31? Yes. How many? Not 1 always. You only record 1 if it's under binary. So when it can, then you now ask yourself how many times. Now, how many times can 24 go into 31? It's only once. Okay, so you now write 1 here. Then you do your normal multiplication. 1 times 24 is 24. Okay, the 24 will be under this 31. You won't take it here because you have not done anything with this digit. Okay, so it will be under here. You know our normal approach. You check for any remainder. So you do the normal subtraction. So you see that under multiplication, addition comes, and under division, subtraction comes. Okay, so you do your normal subtraction. 1 minus 4 can't go, so you borrow 1 from here, and then this will be 2. Remember, you are in base 5. Don't forget. When that 1 comes over here, it becomes 5 plus 1, and so which is 6. And 6 minus 4 is 2. Okay, so you now bring down the other digit, which is the last one, and that's 4. So you have 24, and 24 will divide 24 to give you 1 as well. So 1 times 24 is 24, and when you subtract, you have 0, 0. So you are done. Therefore, our 314 base 5 divided by 24 base 5 is simply equal to, of course, you will not write 0 when it's in front. So it's just equal to 1, 1 in base 5. And that is the solution. This is exactly where we're going to end it for this video. Like I said, in the next video, very important, you must rush to come and watch it. I am going to be bringing you all the questions that JAMB has asked in the past question from 2010. You know, it may not get up to date. If I'm able to get up to date, but it will reach at least 2019 thereabout. So you will see all the questions and the manner in which you will handle them. They are very simple questions. And then we'll see other examples on operations. All of them, they came from operations, and some of them from conversions. Okay, so it's not a big deal. And then in that video, we will touch modular arithmetics. Okay, so kindly remember to subscribe to the channel. Share this video, share the video, the playlist to your friends in all the states of Nigeria. Let them see the channel. We have started a good Jesus walk on JAMB mathematics. Subscribe, and then also, like I said, join the membership. You can join the membership at any category. It is going to be, a support system to help us publicize the channel to many other persons who are in need of content like this. We'll see you in the next video. Bye.